How's it going, guys? It's Mr. Milton here. Today we're going to start a new unit dealing with solving quadratic equations. And we'll look at today graphing quadratics, or at least how to set up graphing quadratics. So we won't get all the way into it, but we'll talk about some important things that we'll use as we go through graphing. Um, there's a few steps to the process, and so we'll deal with one of the most important steps today in finding the middle of the parabola and being able to find the vertex of a parabola and knowing whether it's going to be there's going to be a high point or a low point in that parabola. Okay, so from first semester you should kind of remember what y equals 2x squared minus 5 is going to look like. Okay, because we have that squared term, we should know before we graph that the graph will have a U-shaped curve because of the squared term. Okay, and this U-shaped curve is called the parabola. Parabola. Okay, we also know that the parabola will open up because the a value is positive. Okay, and since it will open up, okay, that means that the parabola will have a minimum value. We'll graph it and I'll talk about all this to make sure that we understand. Okay, so our usual values, if you guys remember our function chapter from last semester, kind of usual values that we will use is -2, -1, 0, 1, 2. And we could just plug these values into our equation and see what comes out. Okay, using your calculator will make it a little bit easier. Let's see if I can show my calculator and you guys can see it if I use it up here. That helped out. Alright, sweet, that helps a lot. Okay, so our function, we have 2. I'm going to make sure I insert my numbers in parentheses. -5. Okay? And that when x is 2, or -2, y will be 3. And I'll just go in here and I'll edit this, change it to -1. Becomes -3. Go in now, change it to 0, -5. Change it to 1, -3. Change it to 2, 3. Okay, so those values, you can use that calculator as I've done that. And now we're going to plot these points. So I have -2, 3, so -2, 1, 2, 3. -1, -3, 1, 2, 3. 0, -5, 1, 2, 3, 4, 5. 1, -3, and then 2, 3. Alright, so you see our points, and we can feel kind of good about it because it does make a U-shaped curve. Notice these arrows mean that the graph is continuing to go up forever. So if I said what's the highest point, you wouldn't be able to answer it because it always goes up. There's no maximum. But you see that there is a minimum here because at no point does the parabola go below that. Okay. This parabola is symmetrical. Okay. Meaning that there is a line you can draw that cuts the parabola in half. Okay, this line is called the axis of symmetry. And it'll be really important for us to know that as we go through this graphing parabolas and quadratics this chapter. Alright, so let's look at this. we have y equals x squared plus 6x plus 5. We're going to create a table of values. Take a second to do that if you'd like to. Alright, the thing about these values, because I know a lot of the times people say, well, why do you choose those numbers? Well, we choose these numbers because they're default. They're just our fallback numbers. They're positive, they're negative, they're low, they're zero. We get to see what happens with x as x changes on different parts of the graph. But when we plug these values in, and I'll do the calculator thing, -2 squared plus 6, and then I'll put -2 in here, plus 5. Okay, when x is -2, y is -3. Okay, do the same thing with -1. Zero. Same thing with 0. Delete, make that 0. Delete, make that 0. 5. Do the same thing with 1. 12. Do the same thing with 2. 21. Okay, looks a little bit different, but let's plot it. -2, -3, 1, 2, 3, -1, 0, 0, 1, 2, 3, 4, 5, 1, 12. I'm not even going to be able to fit that on here. What do we notice about this graph? Okay, what you should notice is that this should, because of our squared term, be a parabola. But as we do our graph, it doesn't look like a parabola at all. Okay, it just looks like it continues this way. What do we do wrong? Okay, why isn't this a U-shaped curve? Well, the reason that this isn't a U-shaped curve is because we didn't find the axis of symmetry. Of the parabola. Okay, the axis of symmetry is the middle of the parabola. It's the line that cuts our parabola in half. And since we know that it's going to be a U, our table really should line up with our graph. And the middle of our parabola should also be the middle of our graph as we've had up here. Okay. Okay. The middle of the parabola is where the parabola changes directions. That point at which that occurs is called the vertex. Okay. And the vertex is the x and the y. Okay. The axis of symmetry always goes through the vertex. Okay, so you have to find the axis of symmetry in order to find the vertex. Okay, we find the axis of symmetry to find out what the middle of our x value is going to be, and we use that axis of symmetry to find a vertex. We'll do that on the back here. Okay, so the first thing you should do when graphing a quadratic is to find the axis of symmetry. Okay, and then the coordinates of the vertex. We're not going to completely graph a quadratic today, but we are going to set up how we should set up. We're going to set up our process to graph a quadratic. Okay, so first, to find the axis of symmetry, we're going to use this formula. X equals opposite b over 2a. Okay, and these letters, actually first, notice that the axis of symmetry is a vertical line. Okay, remember from our graphing chapter, we had x equals a number, let's say x equals 2. I always say, well, where does x equal 2? Here. Where else does x equal 2? Here. Okay, so what do we see about these? Makes a vertical line. Okay? And this is why the formula starts with x equals. Okay? X equals always makes a vertical line. Alright, now notice that the a and the b come from the general form of a quadratic. Sounds mathy, but remember last chapter, or our factoring chapter, when we looked at quadratics, we had ax squared plus bx plus c. Okay, so a and b come from those places in our formula. And since the axis of symmetry goes to the vertex, when you find the axis of symmetry, you've also found the x-coordinate of the vertex. Okay, and that way, in order to find the other coordinate, use your x value, plug it in, and you'll solve for your y value. Okay, if that sounds like a bunch of words, we'll put it into action in these next few problems. Alright, so here we go. Axis of symmetry. We find that by using x equals ax squared plus bx plus c. I'm going to put this over top just now so you can see what the value should be. So our formula is opposite b. In this case, b is 8, so opposite b will be negative 8 over 2 times a. A is 2. So we have negative 8 over 4. Negative 8 divided by 4 is negative 2. So our axis of symmetry is x equals negative 2. In order to find our vertex, we are going to plug this negative 2 into the equation. So 2 times negative 2 squared plus 8 times negative 2 plus 11. Okay. Okay. So 2 negative 2 squared plus 8 times 2, negative 2 plus 11, and that gives us 3. Okay, so that gives us 3, so we know our vertex should be at negative 2, 3. Alright, here we'll do the same thing. X equals opposite b over 2a. For this problem, notice that our b is 0. Because our b is always the number that's by x. There's no just x here. So x equals 0 over something. In this case, it's 10. So our axis of symmetry is at x equals 0. That means it's right on the y-axis. Right on the y-axis. So we'll plug this value into our equation, and I don't need a calculator to do that. Y equals 0 minus 8, which is negative 8. Do one more here. X equals opposite b, so b in this case is negative 6. Opposite b will be positive 6 over 2 times a. A is 1/2. So 6 over 1 equals 6. Our axis of symmetry is at x equals 6. Okay, our vertex will be, we'll plug 6 into this equation. 1/2 times 6 squared minus 6 times 6 plus 13. We'll do that really quickly in here. So 1/2 times 6 squared minus 6 times 6 plus 13. And that gives us negative 5. So 6 comma negative 5. Alright? And so we found the vertex of each of our graphs here. And now when we made our table, when we talk about this tomorrow, when we make our table, this will always be in the center of our table. We'll always make sure that this value is the center of the values that we use. Okay, so since we're here, we're going to talk about kind of the real-world applications that we could use this for. And we'll do that with the problem. You see a lot of parabolas or quadratics and kinetics talking about gravity and falling and all that stuff. And so let's look at an example. It says a tennis player hits a ball over the net. The ball leaves his racket 0.5 meters above the ground, and it sets up this equation that h equals negative 4.9 t squared plus 3.8 t plus 0.5. And that gives the ball's height. H is the height in meters, t is the time in seconds. Okay, what direction will this parabola open up? So first of all, if we just think about a tennis ball, if you just think about somebody hitting a tennis ball, it looks like this. Okay, if you kind of see the parabola here, this will open down. See if we had our graph that continues. It opens down just kind of off how you would see it happen in real life. But based off the equation, the a value is negative, so you know it opens down. That means that the parabola will have a maximum point. Okay, that means it'll be a high point. Now, if you think about like, oh, but it hit the ground, it has a minimum too. We'll think of this as like theoretically it can continue down forever and ever and ever for always. Okay. All right. So that's just kind of looking at some of the basic stuff from the equation. Let's talk about when the ball will be at the highest point. Okay, when will the ball be at this highest point? Well, based off of this diagram, it'll be at its highest point here, at the vertex. Okay, the vertex known as the maximum. Okay, but it doesn't say how high it's going to be. It says when will it be. If you think about our graph will look something like time here, height here. And so he hits the ball, goes as high as it goes back down. Okay, so this is saying when, like as far as time. When will this happen? The line, or the point that will happen will always be on the axis of symmetry. That's where the vertex will be. And so if we find the axis of symmetry, we'll find out how long or when it'll happen. So let's do that. We have x equals opposite b, so negative 3.8 over 2 times negative 4.9. Negative 3.8 divided by negative 9.8. That's what you'll get with 2 times 4.9. And that equals 0.3. I should put this in here. Okay. That will equal 0.388 seconds. Okay. Always important to remember what you're measuring. T is in seconds. H is in meters. Okay, and then it says how high will the ball be at that point? Well, we can figure that out because here's the t value or x value. And so we'll plug in negative 4.9 times 0.388 squared plus 3.8 times 0.388 plus 0.5. And that should give us our height because our equation says height equals that. So negative 4.9 in parentheses 0.388 squared plus 3.8 in parentheses 0.388 plus 0.5. And so 1.24 meters. That's as high as it's going to be. Okay, alright, so hopefully from the video you're able to see how to find the axis of symmetry, also how to find the vertex using the axis of symmetry, and kind of why we need that, why that's important for us to graph parabolas.